Hey, what's up guys? Today we are going to do some trig substitution integration. It's one of the 4 techniques that you're going to be expected to know on your tests and midterms and such. Today it's this one, evaluate the integral -3 over x squared 25 minus x squared dx. Okay, so first things first, the hardest part about integration, I would say, when you're given a new integration problem is figuring out which method you're going to use. Once you know that method is going to work, it's just a mechanical process. It's a pretty mechanical process. So the first thing I want to address is, how do I know I'm going to use trig substitution on this one here? And the answer is, I don't. Okay, the answer is I have hints for it. It doesn't always mean that the hints lead to a certain method working out necessarily. You need a lot of practice. Okay, the hints for trig substitution in this one are that I have something squared here minus something squared here. So it looks like Pythagorean theorem a little bit, okay? That's the hint. So that's why I tried trig substitution at first, and it happened to work out, okay? If it didn't work out, I would have had to do something else. I might have done like arc sine or something like that and split it up by parts or something like that, okay? So just keep that in mind. You need lots and lots of practice with these things. The web work is not nearly enough before a midterm. Anyway, so let's set this up. Okay, how do I go from knowing it's trig substitution? Now what's the next step? Well, the next step is setting up your triangle. Okay, so I set up this triangle on the side here. And I put x here and a 5 here. How the heck did I know to do that? Since it's 25 minus x squared, that has to be the hypotenuse in Pythagorean theorem. That has to be the 5 squared. Okay, otherwise it would be a plus here, and then the 5 would be down here. It would be 5 squared plus x squared equals this side squared. But that's not what it is. 25 minus x squared. So that means this has to be 5 squared, which is 25, minus x squared. So it's just an x here. Then the other side, the third side equals that, okay, which is what I have right here. So this is how the triangle would be set up. This x and this 25 minus x squared don't really matter. You can switch them and still solve the problem, all right? I just happen to do it this way here. Okay, once that happens, notice I'm not going over here at all. This is the last part of the question that I'm going to do, okay? The hard part is setting up all the substitutions and doing all that jazz. Once you set that up properly, it's kind of easy actually to go through all the rest of it. Well, much easier than the setup. Okay, now I'm just going to look at some ratios, some trig ratios. So sine, cosine, tangent of this angle, and see which ones are going to help me out the most. Right now it looks like definitely sine theta. Looking at this triangle, sine theta is going to be extremely useful because sine theta is x over 5. I now have a pretty easy relationship between theta and x. That's the key. That's why this one is like, for me, is like, oh, okay, sweet, I want to use that one. We can do 2 things with that. First of all, we're going to need a dx. Notice we have a dx in our problem that we're going to need to turn into d theta at some point. So we might as well use this simple relationship between theta and x. Take the derivative of both sides. That's this arrow here going to the left. That's going to give me cos theta d theta is equal to dx over 5. I just took the derivative of both sides. Okay, now what I do there is I just multiply both sides on this equation by 5 to get dx equals 5 cos d theta. You don't really have to do that. You can if you want. I like to do that. So now this dx here is going to sub out for the red part. See, this red part here is exactly 5 cos theta d theta. Okay, what's the other thing I can do with this? Sine theta equals x over 5. Well, you'll notice that in the problem I've got an x squared. So I'm going to have to eventually sub out an x squared. So what I do is I multiply both sides of this green equation by 5, which will give me 5 sine theta equals x. And then I square both sides. So that now I have 25 sine squared theta is equal to x squared. So this x squared I can sub out for just 25 sine squared theta. Okay, and that's what I do. That's the blue part here. Blue part here is the old x squared. Okay, what else? That's about as much as I can get from the sine theta. Right now I need to get, the other thing I need to get rid of is, I've done the dx, I've done the x squared, the -3, no problem. I need to do this 25 minus x squared. I need to be able to express that in terms of thetas. Because remember, when you do any sort of substitution, you can't leave any of your old variable there. You have to replace it with entirely with the new variable. So if I look at cos theta over here, I get cos theta is equal to 25 minus x squared over 5. Okay, that's great. But I have something over, notice that this is -3 over 25 minus x squared. So this is backwards. This is like, first of all, the constant's wrong. It's a 5 here. And I need to take the reciprocal of this one. So let's take the reciprocal of both sides. All right, that's why you have Don't worry about the -3 right here for now. Pretend it's just like a 1. Or pretend it's still a 5, actually. So 5 there, and then a 1 there. 1 over cos theta equals 5 over that. And then I divide both sides by 5. That's why there's a 5 there, and no 5 here. And then I multiply both sides by -3. -3, -3. Okay, so get used to doing some of those manipulations, some of that algebra, and convince yourself that indeed, if this line is true, that implies that this line is also true. All right? Okay, so now I just want to sub this stuff in. So I get the -3 over 25 minus x squared, which is in the original question, -3 over 25 minus x squared, gets replaced entirely with -3 over 5 cos theta. And there's the green right there, the light green there. Okay, and now I've done the first main job, which was to sub out all of the old variable in terms of the new variable, which is the thetas. Okay, so I've done that. Sweet. Oh, and also, by the way, you can factor out the -3 right from the beginning of the integral. That's totally fine. You're going to get the exact same answer. Okay, so now we just got to kind of collect and cancel things off. Notice there's a cosine at the top and a cosine at the bottom. That's why there's no cosines left anymore here. The -3 comes out. The 5 cancels with the 5, and then there's a 25 left over as well. So -3 over 25, and then the integral of 1 over sine squared theta. That's the integral of cosecant theta, right? Actually, that's the integral of cosecant squared theta. There's a typo here, right? That's supposed to be squared right there. And what's the integral of cosecant squared? It happens to be negative cotangent. Okay, you can just memorize that one from a table. That's fine. You get negative cotangent theta, but what's cotangent theta? This is another important part. You don't want to isolate for theta and then sub in the theta value in there. Okay, that's going to be ugly and messy. Just look at your triangle and get cotangent theta from there. So cotangent theta is going to be this one, adjacent over opposite. So it's going to be 25 minus x squared, square root of that, over x. And that's why right here you have that. Now, where did the minus sign go? The minus sign canceled with this minus sign there. Okay, so it gave you just that, just like that. Okay, and then plus C, don't forget your constant of integration after you do it, because this is an indefinite integral, and indefinite integrals require that constant at the end. Okay, hopefully that helps you with this trig substitution problem. Let me know if you have any other questions. Keep asking your questions. I love your questions. Thank you so much. And yeah, we'll catch you on the flip side. Pieces.